Good day, everybody. Welcome back to the Soil Matters podcast. We have a friend of Layton's on, so I'm going to get Layton to introduce her, and I'm going to just jump right back off again, and you guys can have fun.
Thanks, Ken, as always. Great to see you again. Andie, welcome to the show.
Thank you. Thanks for having me.
Yeah, so I'd love you to just, give us a little background about yourself and how you ended up in this crazy world, at this place.
Oh, yeah. Well, it felt inevitable. It was just a constant call, and I just kept listening. But let's see. My journey really starts in childhood. I was talking with Ken before about this. I just love being outside. I love exploring the insects and animals and things that exist in places outside of my day-to-day experience as a human indoors. And so just always had an affinity for nature and for creating mud pies and for getting dirty. So going into college, I went to Texas A&M University. I thought I was going to go into human health of some kind, and lo and behold, the more I studied human health, the more I realized it really came back to soil health. Everything that we eat and the nutrient density contained within it really relies on the health of the soil. And it helped that I was doing better in my ecology-based classes rather than my medical sciences. So I switched my major to something called Bioenvironmental Science. And that was in the College of Agriculture and Life Sciences and the Department of Microbiology and Plant Pathology. So I was learning a lot of different disciplines in this degree. And in hindsight, I feel like it was kind of the university's way of doing an interdisciplinary degree where you're learning about ecology and hydrology. You're also learning about environmental policy, but also your core traditional ag sciences. So I did take, conventional soil science, but this is also where I got some of my first experience on the microscope looking at soil biology. I actually had a soil microbiology course. The only problem was nobody was connecting the dots between what we were learning in our plant path sciences and conventional sciences, saying, all of these recommended ways of dealing with pathogens, all of these recommended ways of dealing with infertility are actually killing the biology that you're learning about in that other class. So I had to learn that the hard way, just through lived experience and continuing my own education outside of college. So my first job, actually, what really hooked me was a lot of my peers ended up going to environmental consulting firms, and I had to find an internship as part of my degree plan. And I was getting really discouraged through that process of applying to corporate environmental consulting firms. And so on a whim, I just reached out to this vermicomposting facility in Garland, Texas, kind of near my hometown, and said, "Hey, I need an internship and I like what you do. Can I come intern for you this summer?" And of course, they were thrilled to have somebody young and interested join them. And that's where I grew food for the first time. We were building community gardens, and obviously we were raising worms and harvesting their castings. I had a little experiment that I designed to discover, different conditions that would improve the reproduction of the worms, because they were trying to sell worms at the time for people to do vermicompost at home. And that's really where everything solidified for me of my interest in food, my interest in agriculture, my interest in compost and worms, all of that. So, that was in 2011, and here we are, 12 years later. And, it's been a winding journey, because this is bleeding edge stuff. The soil ecology is pretty new when you compare it to other conventional sciences that we're used to employing in agriculture. And it's not been easy, but I just keep showing up to greet my interest where it's been. And that led me to the Soil Food Web programs through Dr. Elaine Ingham's Soil Food Web. I initially was trying to find a master's degree or go back to school, and there's a lack of funding, to be honest, in soil biology. So Hopefully that's changing, but ultimately I found an alternative path and have started my own business doing soil biology assessments with a microscope. And that's where you find me today.
Oh, that's a beautiful story. Abby, you wanted to lead off here?
Hey, I want to know, was Andie, that's an amazing story, and it's just so timely for what our world kind of needs now. I'm first drawn to was it red wigglers that you were working with?
Yep. Yeah,
And
it sure was.
I'm sure there's a lot of people who are got some red wigglers at home or are starting to work with it and wanting to build their fertility. Can you share some of your secrets on how you increase the fertility between amongst red wigglers?
Oh, sure. So my study mostly focused on their substrate.
Yeah.
So we had access to different materials that we could build the worm beds with. And I basically did different ratios of some of those materials. And I had a hypothesis and everything. My hypothesis was that they would reproduce best in the most manure based mix, because that's where you'd find them in nature. And that one did pull out as the leader in reproduction. In general, anything that was actually able to create more moisture and less significant drainage was actually really great for them for reproduction purposes. Now, that might not necessarily be the best case for vermicompost, which we can kind of get into. But as far as encouraging the reproduction and making them happy and cozy and wanting to have lots of babies, that was it. It was pretty high moisture, and the more manure in the bedding, the better.
And we've I'm in Canada in Nova Scotia, quite a difference than Texas, but we find the same thing, that we find that the more often plant-based products that have a lot more moisture, so watermelons, pumpkins, things like that, you tend to get a lot more increased reproduction in red wigglers that way.
Interesting. Yeah.
Yeah, I was going to ask you if you'd ever heard of avocado tech.
Me?
Or cell tech. So what this is, it started with an avocado, but it can be any hard shell, like gourds, watermelons, pumpkins. You basically cut them in half. You scoop out the inside. You make it like a deviled egg. You mix it with different soils, or not soils, rock dusts, other minerals that you want to get into the soil, because essentially you're getting these taxi cabs, these worms with a biofilm on the outside. As they go down, they're dragging some of this with them. And come to find out that when you did this, you cut it in half, you devil egg it, turn it upside down, put it on the soil or on your compost or your vermicompost or whatever. And what happens is the worms all come up and they basically like have this crazy orgy in there. And then, when they're gone, you just pick it up and you see this ball of worms. But once the food source is gone, they all dissipate back into the soil. But Ab, you've already kind of figured that out with what you're doing.
I think we did it because of cleaning fields, like gleaning fields of gourds. We have a lot of pumpkins around Halloween and stuff, and then just knowing that would be an amazing worm food. So gleaning some melons and cantaloupes. Didn't realize that you could do that. That's a great home-based idea of just.
Well, I didn't invent it. Someone else did. We had another podcast that we had some of the earlier pioneers of that tech on to talk about how well it worked. And they basically doing this indoor on cannabis beds to really encourage that breeding, that expansion of worms throughout the bed, which was interesting.
Yeah. If I can ask another question, this really comes from my own. I did Elaine's course over 20 years ago.
Yeah.
And at that time, I was really excited. Got the microscope out. Got a lot of blueberry growers interested in using a lot of compost teas, and then I became lazier and lazier and lazier. And despite often teaching this methodology in India, we started going to using compost extracts because I said, listen, I don't know what I'm producing with my teas. I'm not checking. I'm not doing the testing. Do you want to share a little bit of why you see the importance in testing and how you might sway somebody who isn't testing to start that process?
Sure. Yeah, I think the testing for me is, I'm not dogmatic about much. So, I don't think that you have to do testing in order to be successful. It's just another tool for us to use. And I like to think of it as, it's the closest you can get to putting your own eyeballs in the soil to see what's going on. Like by taking a sample out of the soil or taking a sample out of your compost and putting it under microscope is as close as we're going to get to making observations in situ, like in the actual pile or in the actual soil. And it's just helpful insight. Like if you're, because we can't see what we're adding, and because on the surface, like with the naked eye, one amendment might look really similar to another, but once you put them under the microscope, they're very qualitatively different. And that's, to me, like having thought that I had a lot of great amendments and to go to, and then developing the microscope practice and starting to put samples of that under the microscope and comparing it to other things, that really opened up my mind to like, oh, how useful this could be, how quickly this could change some of your decision making, because people typically hang on to one product and use it and don't diversify, or they don't because it worked for them once, or they saw a significant yield increase or whatever. But this is a way to, and maybe using an amendment of any kind will slowly, just on a geological time scale, improve the soil health. But only like the microscope is able to help you kind of shortcut your improvements from a soil health perspective.
Yeah, exactly. I totally, I think I've been guilty of saying, oh, this is amazing compost. How the hell do I know? I'm just looking at it, and as opposed to actually getting a soil food web test where I can say, oh yeah, it's backed up quantitatively. Yeah. Sorry, Leighton.
Right.
No. This is a great conversation. So thank you for bringing that up. I mean, Ab, you know me, I'm a testing freak, because like she said, you don't know. And so at least like in my work, I have chemistry, I've got geology, so sand, soil, clay, organic matter, that relationship, and biology. So if I'm only looking at the first two components, I got no idea the relationship of the two that I've looked at without knowing what the biological constituents look like. I could be, if I'm low on protozoa or low on bacteria that aren't mining, where am I going, right? How am I increasing nutrient density and plant health as well as defenses? So I think it's critical, and I've been yelling for years now about how how valuable having that piece of information is, and starting to build data sets of like what's happening ecologically over the different seasons, because that's another whole conversation. And that's why I love Andie, because she'll go there. I mean, she'll go out on a limb and start talking theory, and brainstorm about what's happening in the system as it evolves, both from the start as well as a year later, 2 years later, et cetera. So I'm glad you brought that up.
And so Andie, have you ever looked at a brew after 2 hours versus 4 hours versus 8 hours versus 12, 24, 48, and seen a difference in, I guess, diversity? Would you be able to identify diversity at that level?
Yeah, diversity. So the microscope is limited in that we're not able to identify on like a species level, right? So the diversity is based off of morphology only. So there's a lot of cockeye bacteria, but I can't tell which one's which species. So just to kind of give you perspective on the the limitation there. But to answer your question about looking at a sample of a tea over time, I'm currently doing that kind of work. I've only really done that for some clients, but I'm starting to brew my own stuff, so I'm able to get more granular data. And there's definitely a point at like a peak microbial activity and a peak diversity before things start tapering off. And it's always going to change depending on what you're feeding it. So actually, the more compost tea that I look at, so compost tea being something that went through a brew cycle as opposed to an extract, which is just removing the microbes from a compost substrate into water, is something that's gone through a brew cycle that somebody's added food to. The more teas that I look at, the more I feel like people might be better off just making extracts if they don't have a microscope, or if you don't have testing for it, right? So this is where testing is great, but it's not necessary. Like if you know that you made great compost, and you're able to confirm that in any number of ways through various types of testing, as Leighton mentioned, you could make it a reasonable extract. But the moment you start adding foods, you're changing a lot of what's possible there with that biology, for better or worse. And in a lot of cases, people are increasing their bacterial biomass without realizing it, and our soils don't need more bacteria.
And so that's why you're saying you'd be better off with a compost extract than a tea, because if you're feeding your tea, you're going to end up most likely producing more bacteria. Is that what? If you're not testing, why are you leaning towards extracts?
Yeah, I feel like extracts are more foolproof. Not that you're actually foolish if you get your tea wrong, but they're just more they're more reliable for an inoculation. So I prefer advising people, if you're not testing, I would recommend trying to stick in the extract realm. And Leighton, I don't know if you have any comments on that.
Oh boy, do I. So part of the work I did down at Rodale was experiment with all of Elaine's different formulas. Of course, I was capable of using the microscope. I could test every hour, for as many hours as I wanted to. And there were definitely some big trends. And one of the biggest trends was that first you increase the biomass, the bacterial biomass. Then at about hour 24, the protozoas begin to start dividing. And then by hour 30, you've peaked. You've hit the bell curve. And now it's time to get that stuff out there. So those were the lessons that I learned. I also played with different levels of these food sources. And so my sweet spot, after all was said and done, was 1 ounce of molasses to 20 gallons of water was what I found was the sweet spot. When I used hydrolyzate, I had reduction in certain organisms. Every one of those ingredients definitely changes the profile and what's going to be the outcome. And I'm with Andie 100%. After all was said and done, I went straight to extracts and never looked back. And the only thing I'll do is, after I extract it, I'll keep it aerobically suspended or aerated, just knowing that I've increased the biomass density in the liquid. So I'm going to have a greater biological oxygen demand, or BOD. So that's pretty much where I went. But just because I put extract, under a bubbler doesn't mean I'm making a tea. It's still an extract. I'm just stabilizing it. I'm providing the right amount of oxygen so that the biological oxygen demand doesn't get to a critical point and my extract crash. So that's the only other piece of information I'd love to add.
And do you, prior to application of your extract, do you throw in any fish hydrolysate or humic or fulvic acid or kelp extract? You do?
Yeah, if I'm looking to amend the soil as well as inoculate it, which, hey, why not kill two birds with one stone, right? So I'll use everything from kelp to sometimes I'll put mycorrhizae spores in there. But again, this is at the time of application, not before it.
And when you made your teas, did you, and Andie, when you make teas, do you put your molasses in at the beginning, or is it at time of application?
If it's a tea, I would do it before the brew cycle and then try to wait for that time that Leighton was pointing out, like that sweet spot of when you have that reaction from the protozoa. Again, I feel like the whole point of adding molasses to an extract or a tea is that you're basically trying to encourage the proliferation of the bacteria so that you get a proliferation of its predators. So it's not about increasing bacteria to put on your fields. It's about increasing bacteria to have that predatory response so that you can get bacteria predators into the soil system.
And to be honest, Av, I always add molasses at time of application. And the reason being is because I'm trying to increase the biomass or the bacterial biomass to increase aggregation process. So the more bacteria.
You also added it at the beginning of the brew?
No. So I don't brew. So when I'm extracting, it's just water and compost and worm castings, or excuse me, not water, fish brew, worm castings, and my compost.
Yeah.
That's my process.
I meant your study at Rodale.
Okay.
But back then when you were brewing, would you add, I always added molasses only at time of application, never at the start of a brew. And I was wondering, maybe I misinterpreted Elaine's.
Yes. Yes, you did. You're supposed to add the foods at the beginning of the brew cycle.
Okay.
And so when I did this, the only one that I stuck with was using molasses, because everything else reduced organisms. It did not increase diversity, whereas the molasses increased diversity. So that's a great question. I'm glad you asked it, because that's an important point that people have to understand.
And what type of molasses, guys?
Thank you. Unsulfured blackstrap molasses is the only one that you want to be playing with. And again, I'm with Andie. I'm in Andie's camp on this. If you don't have a microscope, don't screw around with brewing. You're just asking to create problems for yourself.
And I like to point out that, like, from a behavioral standpoint, especially when you're passionate about this, we can kind of get into a space where we're making things more complicated than we need to. We're excited to brew that tea, but if you don't know what you're actually brewing, you're better off just doing an extract. So I just like to acknowledge that there's always a human behavior component to everything we do when it comes to making these amendments and these inoculants. And I find the human behavior aspect of creating teas to be more about ego sometimes. Look at I souped up this tea and I brewed it this long, and it's going to be awesome. But unless you're able to test it, you really don't know what you did to that biology in there.
And I think, again, it starts with, you got to know you have biology in your compost, right? So people are like, oh, I'm making an extract. Great. You're going to get an added benefit from the humic and fulvic acids that you've removed from that compost. But to say that you're making a biological inoculant is incorrect unless you verified that compost has the biology you're looking for in it. I mean, I know plenty of, I can't tell you how many people have brought me samples and been like, I make the best compost. I've been doing it for 30 years. And I go, well, yeah, you obviously make a nutrient dense compost, but you have no biology. You have no fungi, you got no protozoa. So what did you really create? Right. And I think that's the other piece that again is so important for people to understand, is if you make a really good compact post and you can't verify it because you don't understand how to use a microscope, or you don't have the experience behind the microscope, then you got to send it off to someone like Andie or some of the other members of the Soil Food Web graduates, so that you can understand that, yes, you do have what you're looking for. And if you don't, now you've got to start changing your formula and your composting process. So that's really important stuff.
And is that what you mainly get? Are people sending in a compost or a soil sample and saying, tell me about my soil?
Yeah, pretty much. I mean, the type of client really runs a gamut. So some people are growing, they're growing any number of crops, right? And they're growing on any number of scales. but other people are managing turf, or they're producing compost that they want to sell as a powerful amendment. There's landscape design and landscape architects that want to make sure that their installation is actually going to survive their warranty period, and they want to make sure that from a biological perspective, they're doing everything they can to set the plants up for success in that way. So really, any person or business that relies on a soil-based system can benefit from knowing what biology lives in there.
And just as a sidebar, there's been times when I have clients that really can't afford my complete work. And to be honest with you, I've just applied just straight molasses and kelp onto fields and actually had a significant benefit. Thickening of the plants, darkening of the color, and less weed pressure because the grass was more competitive and out-pushed the weeds. So, I mean, again, all these things are valuable tools, but you just got to be smart about the way you do it. Like I would never use straight molasses. It's, again, I go with 1 ounce to 20 gallons. That's the sweet spot. So please take my years of hard work and use that use that formula for yourself.
It intrigued me about, okay, like you've got a golf course attendant, and they get a soil test report back from you. What type of recommendations might be very different that you would give somebody who might be grazing cattle on a pasture?
Yeah, that has a lot to do with human behavior too, and just like culture and precedence. In the industry, in the turf industry, everything's about aesthetics, and the context of what's happened to that soil system historically is really important. I mean, in any situation, just understanding the history of what's been applied there, understanding the other characteristics of the soil, as Leighton's mentioned, the physical aspects, the chemistry of the soil, all of that matters. And we want to take it into account. So when it comes to turf, oftentimes people are trying to control aesthetic really strongly. They don't have as much grace for nature to do its thing as, say, a regenerative rancher might. So usually what that calls for is a tapering off of synthetics, but not a cold turkey turn of that valve. It's about helping them understand how much of their synthetic inputs can they be using without killing the biology that they're using to inoculate, and how can they start kind of tapering that back. And in turf, I don't know that you'd ever get to a point where you're not using some amount of synthetics, again, just because of the culture there and that industry of having control over aesthetics at all times. The biology can certainly tolerate some amount of that, and help improve the health of the turf. But I've kind of found that we have this unnatural expectation of what green turf is. Green turf is not quite as green as like when it's being pumped with synthetics. So there's a lot of just consideration for the bigger context when somebody's transitioning to more biological based methods.
That was a great segue into the Cowboys, Andie. Thanks for asking that. So a superintendent from the Dallas Cowboys reached out to me about 5 years ago. He had a good understanding of the importance of biology in the soil, but he was also from a traditional superintendent education, which is synthetic. Don't worry about the biology. Doesn't matter. He had taken it to the next level, was doing all different types of testing, and he was referred to me because he understood that I had an inoculant that did have high levels of protozoa. So we went through a series of sessions together, application processes, methodologies for getting that transition from the biology into the soil appropriately. And then, of course, we had a couple of disasters where the field had to be ripped out and redone and reset. So that was a great lesson for all of us. Now, when it comes to what the turf looks like, that is super important for Chris, because this is, you know, this is the big leagues. But more importantly, and this is really important, really incredible, because I didn't understand this at this level, was that he has a test instrument that basically has like 3 prongs. He stuffs the prongs in the soil, and then he has a ratchet that he twists. And basically, when the grass cuts loose, it stops the meter, and it tells him how far he could twist, how much pressure he could put on that plant's root systems before it failed. Mm-hmm. And the reason that is so important is because these guys, you know, these monster men, jacked up, are running around on, you know, this size square foot with spikes sticking out of them. So the ability to tear up the turf is huge. So Andie, I want you to anecdotally talk to the audience about what you see in his samples, because it's incredible.
Oh, sure. Okay. So, well, first of all, in case anyone's interested in getting their own instrument, it's called a torque meter that he's referring to, that prong, and it's really common in the turf industry. Ken, if you could, we have, or maybe just share my screen, and I'll click on some biological data we have here. So if you can see that. All right, Leighton and Av.
Yeah, it's coming through clear.
Okay, great.
You can see it.
Okay.
All we're seeing right now is your data, though. We're not seeing any images.
Okay, and you can see my cursor, right? Okay. So this is basically a historical data set of what we've seen in the soil on the practice fields in Frisco for the Dallas Cowboys. And initially, when we started working together in November of 2021, I'll kind of give you guys, because we're going to be looking at so many different biology reports, I'll kind of just give you a brief overview of how I would interpret one of these, and then we can get more specific about what we're seeing trend-wise with this particular data set. But the first thing that I would go to is the fungi to bacteria ratio.
Can you zoom into that a little bit, Andie? It's really hard for us to see it.
Tell me if this is making
Leighton,
it easier for
you tell us when it's good.
Can you widen that? Can you like spread it out, Andie, so that you take up the whole screen? Or is that not? Is that something on your end, Ken? All right, that's better. That's a lot better.
Okay, if it's perfect. Like this, I just can't see you guys, so you'll have to talk to me if you're trying to get my attention. Because this is taking up my whole screen. Okay. Yeah. Okay, so the fungi to bacteria ratio is relevant to ecological succession. And so all of these values here on this part of the report are what's recommended per Dr. Elaine Ingham's Soil Food Web institutional knowledge. They basically have recommended ranges depending on the succession of your plant. And so these values will change depending on what you're growing. Like this whole recommended range would be different for someone who had an orchard and was growing trees. But for he has 2 different kinds of grass species, Bermuda and rye, and we want to get them just under a 1-to-1 fungi to bacteria ratio. And his is starting out at 0.2. So if you know that it's low, one of 2 things, or maybe 2 things at the same time, are happening. Either the fungal biomass is low, or the bacterial biomass is really high, or both. Either you have, or you could have high bacterial biomass at the same time that you have low fungal biomass. And so to know which one of those scenarios we're in, I bring my attention to fungal biomass and bacterial biomass. And so this fungal biomass is on the low end of what I'm aiming for, where this 724 micrograms per gram for the bacterial biomass is actually kind of in the middle. So he definitely needs to increase fungal biomass. And if this decreased, that's fine. If it slightly increased, that's fine. But we don't want it growing too much, because that would, in order to improve the fungi to bacteria ratio. So I kind of want to talk a little bit more about fungi to bacteria ratio and why we're so focused on that. I said it's related to ecological succession, but what it really comes down to is nutrients, the types of nutrients that are being cycled. So the more fungi you have in a soil system, generally the more nitrogen you have available as ammonium, whereas the more bacteria you have, the more nitrogen is in the form of nitrate. And so some plants prefer more nitrate compared to ammonium. Some prefer more ammonium to nitrate. Some prefer quite a bit of both. And that's where this fungi to bacteria ratio can help us kind of gauge whether or not the plants have access to the types of nutrients they prefer, they evolved with. So the next place that I go on a report are to what I'd call the predator groups. So that's like pretty much everything from here down. So protozoa, your flagellates and amoeba are considered our beneficial protozoa. And we want to see those over 50,000. Typically, I'd actually say over 100,000 would probably be where I would target for most situations. This is what's responsible for cycling the nutrients. As the predator eats prey, the byproduct of that is a plant available nutrient. And same thing with the nematodes. So we want to see that if you have enough fungi in your system, we'd like to see that you also have something preying on the fungi, and that's where the fungal feeding nematodes come in. Now, predatory nematodes are useful when, especially to keep down root feeding nematodes, so more of a pest, kind of pest control as predatory nematodes. But of course, if a predatory nematode were to feed on one of your bacterial or fungal feeding nematodes, that's cycling nutrients as well. And so lastly, on a report like this, you'll see a section with detrimental organisms. And that includes oomycetes, which are a type of fungi that typically, it's not that all oomycetes are detrimental. It's just that a lot of root rots and molds and mildews, the things that generally thrive in more anaerobic environments, belong to this family of fungi. So we just want to keep a pulse on that. And then ciliates, similarly, ciliates, they're not directly harmful to plants. They're just a really helpful indicator organism for low oxygen conditions. So especially in the context of a turf field, that's seeing a lot of compaction. Ciliates have been a really important data point for us to keep a pulse on over time, because as you see throughout time, he's had a pretty significant population crop up, and that helps him know when to aerate the field and take some responsive measures. And then lastly, root feeding nematodes, unfortunately, we've seen quite a bit throughout the field across the history, but you'll see that that's also been met with some responses in predatory nematodes. And this is something that you wouldn't see predatory nematode populations responding to root feeding nematodes in an environment, in a soil that wasn't being biologically managed, because typically the pests and pathogens can just have free range because they're not being outcompeted. They're not being suppressed in any way. And so I'm encouraged that at least when we've seen some amount of root feeding nematodes, in some cases we've also seen predatory nematodes to help kind of respond to that population. So I'm going to pause here, and Leighton, if there's anything you want to add or not, I can continue on with what we've seen historically.
So yes, I think it's important to add in that when we saw that real outbreak of root feeders was when they added a strip of new turf in the middle of the field. And I should have sent a picture to Ken on this. I'll try to do it when you're next talking. So when they brought in the new turf, it was obviously a synthetically grown turf that they laid down on a biologically managed field. And the entire new grass turned yellow. and put a big shit stripe in the middle of the fucking cowboy field. Thank God it was the practice field. And again, this was against Chris's wishes. He had no choice. His boss demanded it. So what are you going to do? You got to do what your boss tells you to do. So interestingly enough, though, at the last test, they're gone. And again, this is related to the fact that he is being a biological steward of this intense field. So why don't you continue on?
And Andie, if there's any opportunity where you might be able to highlight that there was a practice implemented in between those dates.
Yeah, I was thinking that too.
That might be interesting to see that, oh, there was an aeration. They aerated the field between June and September or something like that. That might help us understand, or if there was a spray done.
All right, before we go too crazy, when he aerates, he always adds compost in. So he does what's considered like a compost dress. And then he runs a dragger across it to really work that stuff down into the holes that he aerated. So that's one factor. And the other factor I want you to talk about, Andie, on as far as pumping the liquids out onto his field before we keep going. I think that's important.
Yeah. Av, I think that occurred to me when I was preparing for today, because of course, like every time we look at this data set, we're reminded of what happened when, even though it's not depicted on this image. But I highlighted September 22 because this was the hell strip that got installed. There was some panic about how the field was looking, even though the torque meter and like the quantitative analysis of the field was healthy. It just aesthetically wasn't what managerial folks are used to seeing. And so they, made an executive call there. And this data set, I'm sorry, I can't highlight it by itself, but the September of last year was what we saw after that that new grass came in. And so what was disappointing about that was that we had been working on improving the biology, and I lost sight of my...
Yeah, Ken, I think we lost the screen share. There we go.
There you are. You're back.
You're back.
Oh, I'm back. Okay, but it actually closed out the PDF reader on my end, which is no bueno. Let me get it back up. Okay.
So Ken, I just sent you a text with a picture of the field.
I got it. I'll have it up in a couple of minutes.
Perfect. Thank you, brother.
Oh, darn. Is there?
Hopefully it didn't crash on you.
So, Layton, do you want to just speak a little bit about the shit streak? Was it because there were synthetic nutrients?
So the grass itself was grown purely on synthetic fertilizers, and in that environment, a lot of times these guys actually grow on like a substrate that's you wouldn't think about makes sense. In other words, they'll grow on a wood chip base, or they'll grow on a compacted sand base. And part of that is so that when they go to sod, to cut the sod, it's easier for the sod cutting machine to go through. And these are big rolls. They're not the little rolls that we get at the Home Depot. So it's a serious thing. And then you also have to take into consideration that when they're installing the sod, these guys are walking all over the field and transferring all of these pests into the new or into the existing soil. So that's why we had such a big outbreak, is because when they're stepping on the dirt and packing down the sod, they're of course walking across the fields and transferring all of those root feeders throughout the entire field. So I pretty much got pissed, and Chris was laughing at me because I wanted to yell at his boss. I'm like, what were you fucking thinking, dude? I mean, look at that.
How long did that take? How long did it take from being, relatively green to looking like this?
24 hours, 36 hours tops.
Really? Okay. Wow.
I mean, that's what happens when you throw synthetic grass down on a biological field. You're gonna have a freak out. The plant's gonna go, it's gonna stress the hell out. Eventually, within a few months, it came back, but it was, he was balls to the walls trying to do every trick he possibly could to get that to come back. And before we go too much crazier, one of the most important things that I wanted to say when I transferred the conversation over to Andie was about the root balls. I mean, when he takes a core plug, I gotta bend. I have to snap the damn thing because the roots are so caked into this matrix, and the matrix itself is an engineered soil, so it's all sand with very little organic matter. When I first met Chris, he freaked out when I started talking about organic matter and how important it was for the soil system or for the biology to survive. Again, protozoa don't do well in 1% organic matter. Fungi can't exist in 1% organic matter. So I did explain to him, look, I can triple wash my compost and you will get what's called high concentrated bacterially dominant or bacterially motive. How do I say this? Well, it's basically living humic acid. So because of the bacteria and the biofilms, the humic acid can quickly bond all of the sand. Like one of the earliest experiments I do, well, it wasn't an experiment, I had no choice, was an engineered soil system back on the East Coast that I had to do for Sotillo because he couldn't get fungi and protozoa to hold. So I gave him 2 applications of my stripped product. And within 3 months, I think it was 8 inches of looked like dirt, but it wasn't. It was humic acid and bacterially coated sand, but it held water. It performed. It didn't compact. It met all of the requirements of an engineered soil, but it also provided enough nutrient locked up in that sand for the fungi and the protozoas to take hold. So this is something else that he learned that, okay, so I don't have to freak about organic matter. And he got the balls to actually start core drilling and top dressing with compost and raking it in so that he was actually building some organic matter back into the soil profile.
Yeah, and in a system like this where it's just seeing constant disturbance from the traction of the players, it'd be impossible to be truly regenerative. Like that's not the point here, because it's just constantly being disturbed. And from an ecological perspective, disturbance is constantly pushing you earlier and earlier into succession. The point is that every time there's been disturbance, he's responding to it by kind of re-inoculating and shifting it back into that succession range so that the grass always has what it needs to thrive. So I like to point that out because people are like, oh, are they are the cowboys just trying to go regenerative? Are they trying to sequester carbon? And that's not really the point. The point is, what I get excited about is that somebody so mainstream is interested in using biological methods and they're doing so successfully. A lot of people think that by having all the control, pulling all the levers of your NPK and your pest management techniques that you'll actually have a more optimized field, but that's not what we're seeing. We're actually seeing that this field is a lot more resilient than something that's strictly synthetic.
Did Chris notice a reduction in the amount of water use?
That's kind of complicated. The extreme weather has thrown all of that kind of data all over the place. Andie, talk to us about the weather down there. It's just been insane.
Okay, so it's extra complicated at this particular site because the field is in between 2 skyscrapers. They're at least 10-foot or 10-story tall buildings on either side, and they're made of freaking glass. So it reflects the light at the hottest time of year, and it's magnifying that heat onto the field, which scorches it. And again, he was seeing more stress when he was more synthetic and less biological, and he's seeing more resilience the more biological he gets. So there's a lot of things working against him there, not only the sunlight and heat, but it's a wind tunnel too because of those structures. So Texas is just batshit crazy. 3 weeks ago we had a freeze and now I'm sweating in over 80-degree weather. So And that happens within like 24 to 48 hours. Sometimes we go from 80 degrees to 20 degrees and then back up again. So yeah, it's kind of what's important about managing biologically then, given the extreme weather context, is that the more we can use indigenous microbes, like using materials that came from Texas, the greater resilience I would expect him to have. But also, as we've seen, there's other things to consider, like if you're using salt-based fertilizers, you also want maybe some salt-loving microbes to also be incorporated in there. So there's a lot of different working parts to think about. But I'm pretty pleased with how they've improved over time.
And you're not even talking about the reclaimed water, which is high in sodium and other shit, right? So he's got his work cut out for him. I'm telling you, I was there when that sun reflects off those buildings. It's like being the ant underneath the fucking magnifying glass. I mean, you get cooked, dude. It's crazy.
This is perennial rye?
He mixes it up.
Yeah, Bermuda, is it like 50-50 Bermuda perennial rye?
No, he does a complete overseed. Yeah, he does a complete overseed, and he has a fall, winter rye, and then a summer. What does he use in the summer? What is the summer? Bermuda.
Oh, it's an annual rye.
Yeah. Mm-hmm. Yeah, so he just overseeds it when he knows the other one's about to die off, and then when the pressure of the sun comes, he knows the rye is going to die off, so he overseeds with the Bermuda.
Oh wow!
Okay. So
that's really common among landscaping here too in Texas. So a lot of people who have landscaped lawns, they do the same thing with overseeding rye.
Okay. And have you heard back from any of the? Does Chris hear from the players about any feedback around the field?
Chris hears back probably the most from the coach. I think the coach has a lot of preferences when it comes to turf. My understanding, I'm not much of a sports fan, so but my understanding is that Coach McCarty, when he worked at Green Bay, they're like very well known for having some of the best turf under very extreme conditions there as well. They happen to be very different extreme conditions than Texas, but he prefers the players practicing on the grass turf as compared to the synthetic turf that they have actually more practice fields that are like fake artificial turf. So this field sees a lot more activity than maybe it would if a different coach was, leading the team. But the reason for that is pretty well known, I think, among the industry is that you see fewer injuries. The players tend to have greater stamina when they're working on grass turf compared to artificial turf. But then of course, during the Super Bowl, I was hearing a lot of commentary about how the real grass turf there was actually too thick and too grippy. And so that's why that torque meter and like finding balance and constantly checking in and testing is really essential in that industry.
Yes, and the other thing too is Chris is a very much an unsung hero. He never is allowed on the field when they're practicing, so they're like ships in the night. He never gets to actually hang out with the players or get feedback from them, because if he's not working on that field, he's doing paperwork. So he's not only a busy guy, but he's very much an unsung hero. And I loved what you said, Andie, because that's spot on. A lot less injuries and a lot more strength conditioning when they're practicing on that natural turf versus the synthetic ones.
And Andie, anytime you want me to bring up the PowerPoint or the slide again, I can.
Cool. I think I'm ready for that. So I'll probably just wrap up the Dallas history and then move into the liquid compost from the Cowboys. Does that sound good?
Yes, perfect.
Okay, and y'all can see my screen because I can't see you, so just audibly let me know.
Yeah.
Cool. Okay, so the big, broad brush strokes here is that in general, we are seeing an improvement in this fungi to bacteria ratio, a huge significance just between November and March after we first started looking at this information. And I think this is real testament to what's not represented on here is compost analysis. So helping Chris determine which of his compost options are actually going to move the needle in the categories that we now know he needs to improve upon. And so by doing that work, that allowed him to make some decisions that ultimately was improving the fungal biomass and thus improving the fungi to bacteria ratio. And then you also have, we've always had pretty good amounts of protozoa activity.
Now, Andie, would they have had much activity on that field in January, February, and March?
No, probably not. In fact, I think they didn't even go to playoffs within this year. And so it's always funny hearing Chris, like, he's like, well, if we lose the game next week, I'll have X amount of time to really do what I want with the field. So
Right.
yeah,
Right.
but of course we want them to be able to have access to it as much as possible. So that was his sweet spot. I think that's why he reached out to me when he did, was because he was anticipating being able to have some time in the like late winter, early spring season before they started practicing on the fields again to do something meaningful from an inoculation standpoint. And that's that we did see kind of the effects of that. And it just continued to improve going into June, which is a pretty extreme weather for us at this time of year in Texas. But then upon that poor decision to change out the turf, we see things kind of take a weird turn. So that fungi to bacteria ratio, is a third of what it had been. And our bacteria is probably is a little bit on the higher end, still not too concerning, but we lost some fungi is kind of the story there. But I was encouraged to see that we actually had predatory nematodes. At this point, I think he might have treated with a biological amendment at least once before we looked at this. So this was not a sample of the synthetic turf. This was, how are we doing with the synthetic turf after trying to, remediate the situation? And then, since then, things have just been, I've been pretty pleased with the field. A lot of this is just maintenance before he's getting ready to put on an amendment or before he's going to aerate. It just helps him make informed decisions. And today we're sitting pretty at a 0.74 fungi to bacteria ratio. And he's in good shape with not even having ciliates right now. So similar to what we were saying about this time of year in March of 2022, right now, there's not a lot of activity on that field. So the disturbance is really low, and it's his opportunity to just get things in a really strong place as he switches over from Rhiz to Bermuda and is prepared for the summer practices that get started in the next couple months.
I think it's also important to say that when you say practices, it's not full-on practice. All right. So when it's full-on practice, that field gets the shit kicked out of it because you got both offense and defense playing on it. There is some practices, they're like 1 hour camps or 2 hour camps on the field throughout the year, which limits his ability to work on it. But they're nothing like a full-on practice. So I just wanted to make that clear. The field is still getting pressure, just nowhere near as much as, during the full-on practice.
Right. Yeah, I'd probably say fall is the worst, like when they're actually competing. Okay, so the last kind of story on art history with the Dallas Cowboys is related to the liquids that Chris was making. So he had a pretty decent compost. I looked at a sample of that for him, did an analysis, and then I asked him, how about you send me a sample of the tea that you're brewing, send me one from the brewer, send me one that's in the spray tank, and then send me a sample that's coming out of the sprayer end. And this ended up being really helpful because what we found is that he had okay compost tea in his brewer and in the sprayer. So I think the tote is what he called the sample that he took out of the brewer tote. And even though it's not anywhere near what we'd call biocomplete, but the point is that he wasn't brewing anything nasty, and his bacteria was like reasonable. It wasn't too high off the charts. So, pretty non-existent fungi bacteria ratio due to just like very little fungi. But he's basically doing a protozoan in infusion at this point, which I'm okay with. He's getting some kind of benefit out of that. He even had some nematodes in that liquid. And then as we move into his tank, which is the spray tank on the back of the tractor that he uses to take across the field to actually apply this liquid, pretty similar results. We had a very similar bacterial biomass, so he's not increasing the bacterial biomass outside of reason. He still has quite a bit of protozoa activity. We lost some nematodes, but overall, we actually lost some ciliates too, which is kind of interesting. And then where it gets really interesting is what the sample that he sent me coming out of the sprayer was basically a lot of lactobacillus. So it wasn't, he essentially lost any kind of beneficial organisms that were existent in his initial tote. So there were no protozoa observed during the main assessment and no nematodes. And I don't think there was ciliates either, but the visuals that we have on this was the bacteria that we observed, even though it's still relatively low, it was all morphologically the same and appeared to be mostly lactobacillus, which is a facultative anaerobe. So this to me meant a couple of things could be happening. One, he probably isn't cleaning the spray tank very well, because to have that much lactobacillus come out made me think that there's probably some substantial biofilms that have built up inside some of the components of the sprayer. Mm-hmm. And number two, something about the pump or the spray head or the plumbing is killing off whatever beneficial biology he did have. So namely the protozoa there.
Sorry, was the tank aerated?
Yes.
The spray tank was aerated, yeah.
Yeah.
And it also has a recirc too, which is what I think did the most damage to the biology. And again, she's spot on. It was when you see that much lactobacillus, you're almost in manure. So that was a significant understanding that, and he realized anecdotally after he got the test results back that the tank had not been cleaned from the guy he had lent it to before. Don't lend out your biological tools, people. People don't care.
Real basic question, Andie. How do people actually send samples to you?
That's a great question. So sampling is like a whole conversation in itself, because we want to make sure.
If this isn't the best time to answer that question, we can go back.
Yeah.
Yeah. Sorry.
No, that's good. I think this is a perfect time to talk about it. So how long do I have you guys till?
We got just under an hour.
Just under an hour. Okay, great. Sampling I think is really important to talk about, because we always want to be looking at something that's as representative as possible. So again, going back to like the limitations of using a microscope is that you can only look at one drop of anything at a time. And if you're looking across your acreage and you're analyzing one drop, that can feel overwhelming. It's a true limitation. So what we can do to help ourselves collect a sample that is as representative as possible is to just be mindful of making what we call a composite sample. So that's where you take several subsamples and then mix them in one bag, but you want to do that strategically. So you wouldn't want to be mixing, like if you have one bad part of the field, let's just use the cowboys as an example. Like if you had one side of the field that was just really not doing well and one side that looked great, I wouldn't want to mix those two and analyze them. I'm not trying to get like a hybrid reading. I rather have a composite sample of the good area. So take 4 to 6 samples core samples and mix those together, and that's one representative sample. And then take core samples of the not so great area and look at those separately and see what the differences are. Now, when it comes to liquid, or I guess I'll finish kind of the follow through on shipping with that. You also want to make sure that when you're shipping this, that you're not sealing it totally off from air. Because again, these are all of the organisms we want to be encouraging in the root zone are obligate aerobes. And so they need access to air, some kind of air exchange. And so what you can do is just kind of limit the amount of sealing on a bag. So typically a plastic bag, you wouldn't want to put it in something like paper because the microbes can digest that, and that would change the organism population. So a plastic bag and leaving a little bit of an air gap on the end, not like pushing the air out and sealing it is what we're trying to avoid. And then just putting that in a package to ship it to me as quickly as possible. And then I have a personal protocol of looking at anything that was in relationship with a plant. I try to look at as soon as possible, like within 24 hours, because if that biology has been removed from that environment and it's no longer receiving exudates from a plant, then it could change pretty quickly, especially springtime. That's something to be mindful of. Now, during more dormant times of year, I find that the biology doesn't change as much from the day I get it to it sitting, in a properly stored condition for a few days. But same with compost, because there's not an interaction with a plant pushing out exudates. Those have like a longer shelf life to evaluate. And then liquids are also like an ASAP kind of situation, because the moment you stop putting air into that liquid, it's just a matter of time before it goes anaerobic. So people tend to overnight me liquid samples, and they'll do that in some kind of container that they only fill about a third of the way. So just like a clean water bottle is a great example, just filling that about a third of the way. And you would seal that really well so that doesn't spill in transit, but at least you left 2/3 of that bottle with the amount of air exchange needed to get from point A to point B. And then when I receive it, I usually give it a little shake and open the bottle and try to look at that within 24 hours as well.
Thank you.
Yeah. Yeah. And so like when I told Chris to take a sample from the sprayer, I told him, don't give me the first stuff coming out and don't give me the last stuff coming out. Give me something like a little bit in between, because that's one way to make sure that it's representative and it's not polarized like one way or the other.
I think they call that like midstream sample, kind of the way we do tests, right? But anyway, so yeah, that was some really interesting work that we've developed over the last year. And just anecdotally, I called him and said, "Hey, I give you an A. Let's see if we can get an A+ next year," because he's come a long way since we started working together. Yeah, Lil, he did take a lot of guts, and he's taken shots from the management. On whenever there's anything that goes wrong. He is a bullseye on his forehead, but he stuck to it, survived the transition, and now look at what he's accomplished, which is, again, resilience. This is something we used to talk about in the cannabis community. Like, this is going to make your plants so much more resilient to the effects of the environment. If these extreme weather events, or you lose power for 24 hours, you're not going to kill it. You're going to be able to recover, and I think that's a really important message to send through.
It's also safer. It's safer for the players to be practicing on this field. They're down in the dirt, every other play. And if I was an athlete, I would much rather play on a field that was being biologically managed rather than sprayed with a million different, half a dozen different chemicals. So there's that. And then, of course, anyone handling these amendments, it's healthier for Chris as well.
So should we bounce on? Did we pretty much wrap up the information we wanted to present on that one?
Yeah, I feel good about that.
All right, cool. What do you want to hit next?
Well, so I'll tell you what I have. I have an avocado situation. I have some of your compost trials, and I have what is this
Ecospheres.
ecosphere?
Let's hit on ecospheres. They're going to be coming on April 27th, and I assure you that's one that you do not want to miss. This is going to be some really, really interesting information. Just to kind of segue into this, these guys created an aerobic digester. I didn't think it was possible. Quick story, when Ken introduced me to Gary, I tried to poke holes in him. I couldn't. I asked him for the inventor. I got Mo on the phone. I couldn't poke holes in him. And they brought this machine down to Peach Hill Soils to demo it for me. And some of the work that's coming out of it is really, really impressive and very interesting. So that being said, why don't you go ahead and pull up the information, and we'll dive right into this one.
And that's May 1st, my friend, not April 27th, May 1st that they're coming on.
Oh, we got moved back from 4/27?
No, it was always May 1st.
Remember, it was going to be 4/20, and I said, no, let's do 4/27. But that's right.
Oh, well.
May 1st is fine. May 1st is
I've been advertising May 1st for the last couple of weeks, so
doesn't matter.
Okay.
I stand corrected. May 1st.
Okay, May 1st.
I love it. Yeah, keep him honest, Ken. I'm gonna lean on you heavily, Leighton, because here's kind of the fun part of working with you is that you have your hands in a lot of different projects, and you'll send me stuff, and I look at them. Oftentimes, I prefer looking at them blindly, like not having any context of what I'm even looking at, and just doing the assessment, because that helps eliminate any kind of bias during the assessment. And then once we have the data set, we can look at it and you can kind of add some color. And so I don't have as much context on these more recent samples, and so you'll probably be the one to add some color here. But in terms of looking at the data and what I see, I'll just point out some of the objective differences, but please chime in if you find reasoning for why some of these differences may occur.
Okay.
So, well, first of all, Leighton, do you want to describe what the samples even are? The aerobic juice, bio only, and bio plus juice?
All right. So at one point, I was doing an experiment with these guys. I'm doing, I think there's 12 of them right now. Most of them, I'd say 6 of them were completed to date, although we don't have all the data assembly because I do chemistry, I do biology, and of course, I do the matrix of what I'm applying these to. So aerobic juice, the first round of testing we did, the juice went anaerobic because the machine lost power for 3 days. They didn't realize it, but they plugged in a golf cart and popped the circuit breaker in the machine and weren't capable of understanding that if it wasn't making noise, that was probably a problem. So that's why I called this one aerobic juice, because this was the product that would be coming out of that process when it's operating correctly. So I think that's just important to notice on that one little thing. But other than that, yeah, let's get into it.
Okay, so yeah, when I look at the differences here, again, just kind of staying true to form, we're going to look at the fungi to bacteria ratio, and we see that there's one that's clearly leading the way there. This is technically over what we consider a biocomplete standard for fungi to bacteria ratio at 0.4. And then I want to investigate why that is. So with a fungal biomass of around 500 and a bacterial biomass of around 1200, they're fairly moderate. Both of these are like moderate values for those particular biomass or populations. Whereas there's much more bacteria in this bio plus juice, and that has an impact on the fungi to bacteria ratio, where it results in about half the ratio, because you have twice as much bacteria, but a very similar amount of fungi.
So it's important to also know that the bio only is my product. Okay. And so I wanted to know what would happen with a biocomplete product added directly to their juice. So that was the grounds behind this test.
Got it. That's helpful. Okay. Yeah. See, you can see me processing this in real time. Because yes, this one's biocomplete, and obviously this one was just really different. The aerobic juice had a greater morphology, which isn't listed on the report, but in the discussion that I provided for this one, the type of bacteria that we saw, even though this is relatively low, it had a greater diversity of microbes. And same with this one, whereas in terms of diversity, we saw less from a morphological standpoint, less diversity in bio only. So the other categories of like predators, we have about twice as many predators in the bio only compared to bio plus juice, and that subsequently meant we had about half as much bacteria. Now, results don't always end up working out this way, but that felt like a really strong trend to me, that there's just generally more predation, more protozoa activity in bio only at the time that it was sampled, compared to bio plus juice. And we could expect that maybe with some time, bio plus juice would have a decrease in bacterial biomass because they have so many active predators preying on that bacteria population.
So here's my 2 cents. What's really interesting is if you look at I'll go back to the report. You don't need to see my ugly face. If we look at biomass, so we've got 559, and then you add it to the biocomplete, and look what the number is. It's not too far. It's just a little bit greater increase in the combination of those two. Now bounce down to protozoa. So we have a different type of protozoa, which I'm going to have Andie speak on in a minute, in the anaerobic juice than you do in the bio only. But when you combine them together, you have a slight dieback. But in my mind, if we retested this a month from now, you're going to see a rebound in that number. But again, there's diversity here. There's a greater level of diversity, which I think is really important to understand and know. And also look down to bacterial feeders. They really liked the juice. They loved being exposed to the juice.
Yeah, look at that. That was insane.
Right? So we might have to trade off a little bit, people. I mean, that's common in nature. Nature trades off, as things progress. So go ahead and speak on the what you saw as far as the protozoas are concerned.
So yeah, I wish I could pull up my discussion for this. But keep me honest, Leighton. What I was finding in the aerobic juice is they're almost like the amoeba population was. There weren't any testate amoeba. There was just round naked amoeba, and it's just interesting because, of course, if there's a different set of bacteria in that mixture in that liquid, it would also have a pretty different predator possibly preying on that bacteria. And so, in general, there were more flagellates than amoeba in the aerobic juice, but and that's true for the other liquids as well. But there was an increase in biodiversity among the amoebae that we saw here and the amoebae seen in bio plus juice.
So again, what do I preach all the time, Ken? Diversity, diversity, diversity. So, right? And this is a prime example of how you can accomplish that kind of diversity relatively easy. Now, again, not everybody's going to have access to an aerobic digester, but once the trend catches on, I tend to think that there'll be a tremendous amount of that juice available on scale. They're installing a 100-ton unit on a food processing plant, which is going gangbusters in California here, and they have 2 railroad spurs. So we've already talked about starting to ship some of this stuff out to Kyle and the farmers in the Midwest, so that when they add They're biologically complete compost with this biological juice that has, and again, that one of the first tests I did on this was I tested all of the inputs that went into the digestion process, and then I tested the juice when it came out for chemistry, and the result was incredible. All the nutrients were reduced to almost nil. And so where did they go? They're in the bacteria. So what do? We created bacterial superfood. So when that predator eats that bacteria, it is going to be packed with nutrition. So we're on the cutting edge of some really amazing discoveries with this muncher group, which is why, Ken and I have been pushing to really get, I needed to get all of the information first before we presented them on the first now, because I didn't want to, I wanted to have this data set because I think it's really important for us to demonstrate the value of this type of piece of equipment.
Yeah, and the way I see it is like when you see significant differences in the morphology between samples like this, that feels like grounds to then spend the money to get genomics testing or something more specific on that diversity.
The only problem I have with the genomic testing at this point, we might be able to identify that specific species or species or strain, I should call it. Let's break it all the way down to strain. We can identify that strain, but we don't know what its function is in nature, or the ones that we do are still questionable at best. I mean, we know these guys are very diverse and can, through horizontal gene transfer and other biological processes, evolve very, very quickly in the soil structure. So, again, it goes back to, all right, how do I best prepare to convert this dirt to soil? And it goes back to diversity and tools. So I like meta barcoding, which tells me what's been there and what is there combined, because we know for a fact that if a bacteria came in contact with an old RNA, that through horizontal gene transfer, that bacteria could pull that gene up into it and therefore use it as a cookbook. So again, it's getting as much diversity into the soil as possible, giving those, these biological constituents as many possibly tools that we can give them so that they can work for us. So again, that's really important conversation, and that's another whole deep dive for some other podcast.
Oh yeah, and a different guest for sure.
Yeah.
Cool. Okay. Do you want to move on to either avocado or some of your peach hill trials?
Let's go to peach hill trials.
I don't even think you've seen this data yet. I
haven't. That's why I'm asking for it.
It's dated today.
I'm excited to see it.
Okay,
all right.
cool.
So this was a test. I'm trying to build biologically complete compost at scale. Many have tried. As far as I know, most have failed. Now I'm talking scale, like I'm talking hundreds of yards, not 50 yards, not 25 yards. I mean, 25 yards is still pretty big, right? That's a big pile to turn by hand. I'm using, I created a piece of equipment that I call the hydraulic pitchfork. I've taken the pitchforks, prongs or tines and welded on 10-foot long angle iron upside down and put a point on it. And then inside that angle iron, I've filled it with a tubing with holes in it. And then I've got a compost tea, basically delivery tool that's mounting on top of the unit. So I'll be delivering muncher juice, biology, and water as necessary. So this is the work I'm doing now. So the old pile was a pile I did, I think 2 months ago. It hit 120 because my recipe was a little off 5 times, but every time I got to 120, I turned it with that pitchfork. So I kept it and calmed it right back down again. And it's finally gotten to the point where it's under, the highest I could find was 118. The rest of it's like more like 115. And that's the core temperature. I'm not talking temperature on the outside of the pile. I'm talking finding the thermal core and measuring that temperature. So this is why I wanted to include this one. Now I've got 2 different, I have a new formula that I'm happy with now with the old pile formula. So then I took that formula and I did I did blending, and I did layering. So I used the 4 or the 5 ingredients that I was working with, and I just layered them like lasagna. I did not mix them together. On the other one, on the blended batch, that one I mixed it all together with the pitchfork so that it was contiguous. No, what is the term? Well,
Homogeneous.
homogenized. Thank you. And then I also let an area of the blended get to 120. I added a little extra biology to it and cooked it so that I could take a sample of it to prove a hypothesis, a theory. A bunch of people have talked about this over the years, and that is it truly reduce organisms at 120 degrees and above? And so we're gonna suss this information out live here today, because I haven't even seen this yet. So go ahead and present it to me, Andie. What'd you find out?
Okay, so I found, as far as the goal of comparing it to biocomplete compost standards, the closest one was blended B. And just hearing about the differences now, because I'm hearing about the differences for the first time now, I find this really interesting, how different blended B is from layered B. So the one area that both of these is considered not biocomplete is, again, in that fungi to bacteria ratio. But the reason this ratio is what it is different from why this one's so low. So the blended B is low because it just has a really high bacterial biomass, but it has great fungal biomass. Dang, it just happened.
Yeah, I'm going to talk a little bit about that while you try to figure out your computer again. This is something that Andie and I are sussing out. We've been working together for just about a year, or maybe a little longer.
Yeah.
And it's always been about not questioning protocols, but looking at protocols and having an open, heartfelt conversation about how better to suss out information in these, incredibly different types of applications. And is it fair to give, the blended a low F to B ratio just because it had a higher bacteria? Maybe there's a better way to start processing this information. Like I got Andie to start counting spore counts, which is something that no other soil food web lab is doing, and looking at the comparison of not only the spore type, but the spore like I said, types. There's more than one. There's millions of spores. So what are we looking at, and what is the rough count? She's been going through some other data, like whether it's in an anaerobic condition, whether it's an aerobic condition, what is the spore counts potential? All this stuff is really, really. I want to say, I tell her this all the time. We're boldly going where no one else has gone yet, because we're trying to be cutting edge and perhaps influence other people to start thinking this way, because there's more to it than just this. I mean, yeah, this is fantastic foundation, or I want to say the next best step, because the original food, what are they called? Earth Fort. Right. That was a totally different testing methodology than what Andie's doing now. And what Andie's doing now is far more accurate and far more informative than what that test was. But that test was the foundation. It was the only way you could get any kind of biological data. And now that we got this, the next step here, fantastic. But let's not be satisfied with this step. Let's push this step even further to start getting some deeper understandings of these relationships and how important they are in making decisions and what I should do next, or what's my next cultural move. Were you able to get it back up, Andie, or are you still struggling? There it is.
Yep, we got it. Ken's got it. Cool. Okay. Sorry, I don't know if it's my problem or what, but so we're back, and where did we leave off? We were talking about the difference between these.
Right. So Andie, if we used the layered pile of 1782 and we use that number, how would the F to B range change? So if we use that as a baseline and ignored the fact that there were so many more bacteria in the blended, what would our F to B ratio look like then?
Well, I can get a calculator and tell you.
Right? See, this is what you guys. This is what I get to do with her. I have so much fun with this woman.
Okay, so it would bring us to about 0.4 if we are able to bring down this bacterial biomass to what we see in layered B. This would increase to 0.4.
And with that much,
yeah,
right, with that much protozoa, I would tend to think that that's going to happen over time, but not like I want it. I want it now. I don't want geological time.
right.
So that tells me that the blended B process is absolutely the correct way to go about building this type of compost.
But I'll be interested if we look at this layered B later, because if it's allowed a static phase for all of this fungi to continue to myceliate out, you could easily end up with a pretty similar ratio here.
Yep, I agree 100%, and that's why, again, I'm not going to touch that one. Still going to kick around the length of time after you've had a chance to do a little research on your end as to what we think is the best amount of time, whether it's 6 months or a year, to come back and do this again. But again, this is part of sussing out information, is asking these questions and having these brainstorms and questioning each other as to what you read the data like. What does this data tell you? All right, so let's go on to blended B 120 pile. This hit 120 plus degrees.
Right. So this one definitely, just subjectively speaking, it was very clear to me while looking at on the microscope that there's just less diversity, less activity in general. It really read like an early phase compost to me, which tends to have a lot of actinobacteria and high bacteria with actinobacteria. Although the fungal biomass was probably higher than expected, but keep in mind that also had a really high standard deviation. So this is probably a pretty imprecise value. And typically a high standard deviation is associated with lower populations of an organism group. And then protozoa, we didn't even see flagellates actively feeding in this sample. Again, it's not to say that they're not there. It's just that they're not there in the numbers that would be required to evaluate them in a single drop, which generally means they're not in the populations that we want and need to be cycling nutrients if we were to use this amendment. There were bacteria. There were bacteria feeding nematodes in all of them, though, which was encouraging to see.
Yeah, and it's, again, I didn't let this cook over 120 for a long period of time. It was probably got there, and I'd say I took the sample maybe 24 hours later. So it only cooked for 24 hours. So this gives me.
Leighton, do you typically not go to 120? Oh,
never. I never. I like to hit 110. If I hit 115, generally I flip.
You see now, and once again, Leighton and I have talked about this before. I'm a little old school. I don't think you used I think a little more derogatory term. But when it comes to the NOP and I assume the NOP, but I know with the Canadian organic standards, we have to hit 130. We have to hit 55 Celsius, I believe.
Yep.
And we have to hit that 3 times for it to be considered an organic compost. So that's probably 130 or plus, right?
Yeah, I believe our standards are 150 5 times over 30 days is what's
right.
That's for organic in most cases. The 5 turns, the 5 heat cycles is typical for organic certification, but 3 is typical for standard.
Yeah. Yep, and the reason they're doing that is pathogen reduction.
Right.
So one of the ingredients in this particular test is what's called GOM, ground organic matter. Basically, it's all landscape, yard waste, you name it. It could be crazy CDN ratios. You have no idea what it is. Every every lump that comes off is going to be a different type of plant and blend, et cetera, et cetera. So an extremely difficult product to work with. But because there's so much of it, and again, I'm targeting waste streams that are not valuable, excuse me, that have excess in this particular work. So that one, I make them take it to 150. It's called pathogen reduction process, or anyway, that it's a standard. It's a state standard. So I have them definitely cook that, what I call post pathogen reduction GOM, before I take it. Now everything else, again, are byproducts that are not exposed to pathogens. So I call it vegan-based compost making. I'm not using any manures, so I don't have to worry about that. So I'm comfortable. I've been composting this way since I started working with Elaine down at Rodale. I've told this story before, but I'll try to tell it briefly. She had brought in, I think, 10 proteges from all over the country for this summer internship. And so we always had Thursday morning meetings where everybody updated Elaine with where they were and whatever work they were doing. There was always, conversation of what to do next, what they needed to do by the end of Friday, so that next week they were set to, set for success. This particular Thursday morning meeting was the review of compost that these kids made in a bioreactor style compost making process, where they were required to go to temperature a couple of times. I can't remember exactly whether it was 3 times or 5 times or what. They were using 10% high nitrogen of their choice. Everything was their choice as to the inputs they put in. And she got mad at them that morning. And she was like, "You guys, I don't understand why you guys can't make this compost. I've been teaching this for years. You guys are proteges. You should be able to successfully do this. So I want you guys to take the rest of the day, rethink your formulas, figure out what you're doing wrong, and we're going to start over again on Monday." So the following Monday, I asked Elaine, can I join the competition? And she said, "Sure, go ahead." So I think it was 60 days later, or maybe it was only 30 days later, pretty quick. We all came back in on a Thursday morning meeting. She reviewed all of their latest tests or samples from their latest compost, and again proceeded to get pissed off at them. Then she took my sample, put it in the microscope, took a look at it, and was like, "You guys, how is it this uneducated guy that comes into Rodale can make better compost than you? What is wrong with you guys?" And so I was embarrassed, right? I was horrified. And then she looked at me and said, "Well, Leighton, you know what? How did you do this?" And I kind of said, "Well, I cheated." I said, "This is what I did. I didn't build it in a cage. I built an eco pile, put an old rotten log in there. I layered my stuff the way I build it. And I applied some of my fish manure on it. And so that's how I accomplished this. And so we had a good laugh, and we went to the bar that night, which we usually did on Thursday nights, Thursdays. And we had a bunch of laughs about the fact, and the kids were all knuckling me hard about me cheating. And she was so proud that I had actually accomplished this. So here again, that's where all of this shit comes from. Is like how to do something better by asking why can't I, or at least questioning the methodology. So again, that's why I don't go to temperatures, because again, I'm not using anything pathogenic. It's vegan based, so there's no manures. And so why can't I, right? Why can't I?
Yeah, I think you'd kill most weed seeds by getting to that temperature. So it's really just the E. coli, Salmonella, Shigella.
Right. And again, I'm not worried about weed seeds. I'm not looking to kill them. Like I know you have, if you don't get to like 150, you are going to get a lot of weed seeds. But again, I'm not using flowering plants or seeded plants. I'm harvesting my greens and browns and applying those into the mix. So I'm not, again, concerned about reducing pathogens. I'm not concerned about killing weed seeds. I'm only interested in getting biologically complete compost that I can strip or extract to make liquids. And I want to do it as fast as possible.
So I'd like to just offer a summary and make sure it aligns with what you're saying, but it sounds like these experiments are a way to, in an industrial context, we know that most industrial composters are creating what you refer to as GOM, ground up organic matter, and it's not a powerful inoculant, but you can add a process of introducing biology and cultivating that biology in a pretty short time frame and before actually using that material and selling it. Like, that's option number one. Option number two would be, instead of adding anything, you'd have to put that GOM in a static pile and wait a very long time for it to not even get to the kind of inoculant value that you can get by being strategic about it.
Exactly. So in the last round of work I did in 2022, working with Agriman, which again, these are industrial composters, you would be horrified at the amount of material that rolls in to these places and the equipment they use to grind it up. It's insane. I said, I was talking to their plant manager or that yard manager, and I said, Rob, I want you to, or Billy, I want you to take me to the oldest pile you have, and I want to see what you've created. So he took me to the way back corner of the yard. He said, this pile's been here for about 6 or 7 years. I stuffed the thermometer in there. It was still cooking at 150 degrees. And ironically, they were coming like the next week to do a movie shoot on that back lot. And one of his guys had to go back there and move it. And so when I came back the next week and I was talking with Billy, because I always talk with him in the morning, I told him, I said, dude, I sent that off. I microscoped it. There's nothing living in that shit. And I go, I understand you can't take the time to separate these greens and browns on this scale. It's go 24 hours a day, or not 24, but 7 days a week anyway. So I understand that that's not going to ever be an issue. I said, but the problem is, I don't care how long you let that pile sit. It's not breaking down appropriately. It's pretty much anaerobic because it's just compacted on itself. And it's good as a mulch, but it's not going to ever really turn out to be what you want, which is a fungally dominant or a biocomplete compost, because you're not separating the greens and the browns, and you don't have the time or the space to store this shit for 10 years. So it becomes a big issue. And there are a couple of goals to this too. It's not only am I trying to mix ingredients that are going to be ready in 30 days, it's also about water storage capacity, because that's something that a lot of people don't talk about. When you're getting into biological compost, you're looking for a wetter compost. It's not, if you draw it out, you've insisted everything and probably lost diversity. So you're composting, again, outside of the traditional box of how you compost. And I hate the word compost, because compost is a process. It's not a product. It's not, it's an end result of something. But needless to say, we'll continue to use that word because we really don't have any other descriptive words for biocomplete compost. It should be biocomplete palm, right? Anyway, so back to the point. The GOM that I use is basically the overburden that comes off after the screening process. And the reason I use it is for structure, not for its water storage capacity. It is already at its maximum water storage capacity. If you add water to GOM, it doesn't do anything. It just leaks out the bottom. That's why these guys have to grind it, screen it again, then pile it up so it's small enough that it'll actually start to hold some moisture. The maximum moisture that this material can hold is somewhere between 50 and 55% moisture value. And when I'm doing, biological manufacturing, I want to be at 85 degrees and about 70% humidity or moisture content. So GOM will never be that, no matter what you do to it, unless you can afford to let it sit for years. And none of these guys have the kind of capacity to just pile this shit up for 10, 20 years and let it naturally break down. They got to get it in and get it out. So again, there's a demand for how to utilize this material, but with the understanding that it's going to just take a long time in nature for it to become functional as far as supporting advanced biological life.
I'm curious if anyone on this call knows, like, if because that GOM went through those regulations, like went through the heat cycles, does that mean anything you do after it before the point of sale, is that okay? Or do you have to get, like, are there regulations that could actually limit what you're able to do after that, after you made GOM?
As long as I can prove out that I'm not introducing any pathogens to it, and I have reduced the one component that needed to be reduced, I think I'll be all right. But to be honest with you, I'm not in this to make money. I'm not in this to build an empire. I'm in this to do the work so other people can utilize that work and take it to the next level, because that's what it's going to take. It's going to take rewriting the compost laws. It's going to take or amending them to a point where we are allowed to make biologically complete compost. Because right now you can't. If you cook it, it's going to take significant amount of time to get that protozoan back, the nematodes back, and everything else, and the fungus to grow up. You've sterilized it.
This is like so co-host privilege here. I wanted to jump to some of your videos, and we only got about 15 minutes left. And I wanted to just have you share a little bit more about that, at least the cellulose video, because that's the first time I've ever seen cellulose. And then Layton had mentioned something about counting spores. Do you have a video on what I'd look for in a spore?
Oh, for spores? Sure. I can pull that up if Ken wants to put. I know he has the videos.
Which one would you like? The cellulose one first?
Yeah, sure.
Okay.
And I love you, Ab. Jump in anytime, brother. That's why you're here.
Exploiting the knowledge of Andie here.
Yeah, this is what cellulose looks like on the microscope. So typically, before it's even starting to decompose, you see how there's several strands coming off of kind of one core one. Usually they're all together in one fiber, one really thick, structurally sound fiber, as you can imagine. And then as it starts to decompose, it kind of peels off into these individual tendrils. And so I was actually seeing a lot of these in the aerobic juice, I want to say, Layton, from that set of samples. So the stuff coming out of the digester actually has a decent amount of cellulose that looks really similar to this.
So that's cellulose degrader.
What'd you say?
I was just wondering, do you see a lot of life around that cellulose or fungi or what? No,
I don't. So nothing's feeding on it directly. I've not seen that, at least. In this field of view that we're looking at, as the video plays, I'm not seeing any movement from like a flagellate, for example, but I do see lots of bacteria. You almost always see bacteria in every field of view. The bacteria are basically just the round specks that seem to be vibrating with life a little bit there. And we can scroll through some other examples of other life forms.
Okay, where would you like to go next?
Let's look at, I don't know, Av, if you have requests.
I don't know if I recognized a spore before, so
a spore.
All right. And so while you find the spores, let me also just mention that to decompose cellulose is a really important find, because that is the thing that takes the longest to break down in soil and will not without help of fungi. So that being said, go.
Okay, I'm going to share my screen for the spore example. I have a few that I can pull up because I don't think I had one.
And honestly, anything that you want to share, or what?
Oh, sure.
Maybe whatever the audience wants to know as well, they could write in the chat.
This is
Yeah.
this is an interesting flagellate that Andie found twice now, correct?
Yes. Oh, this is a fun flagellate. Yeah, that's currently on the screen. So that this is like a morphing, I'm calling it a morphing flagellate. And I've actually shared this with a few people that were able to point me towards a species name. Like they were actually able to identify it for me. And I know it starts with an A, but I'm totally blanking on the whole name. So I might have to follow up on the thread here. But you can see that it's pulling itself with its one long flagella there and dragging itself, and the body goes from kind of a mushroom shape to this elongated shape. And this is feeding on bacteria as it goes. So there's actually another flagellum that's wrapped around itself, which allows it to change its movement pattern. So sometimes it'll look like it's swimming or undulating in a different way than the dragging motion. Yeah, like there, how it's kind of spinning around. That's because it actually has a flagellum that's wrapped around itself. So that's an exciting one. We saw that at the Dallas Cowboys field, and I've seen it a few times in their soils. So it seems to be happy there.
It looks like there are some spores in this picture. Those brown ones.
Yeah, that's a good point. So I don't think I can point on this screen, but anything that's really round and smooth, they do come in different shapes and definitely different sizes and different colors as well. So spores might be dark brown, they might be light brown, they might even look pretty clear. Generally, they're just really smooth around the edge, though, and they don't have any activity on the inside. So if I come across like a naked amoeba, it's also really round and smooth, but it has a lot of activity on the inside because it's actively metabolizing, where a spore almost reflects light in a way.
And spores can look like footballs. Fusarium looks like a croissant. So there are many different shapes.
And this is listed as a nematode egg.
Yeah, so you can actually see a little baby nematode in there kind of squirming around, which is always fun. Sometimes I come across nematodes that are pregnant, and so you'll actually see something similar to this inside the body of a nematode. So it's always fun coming across something kind of unexpected.
And then this one we have moving predator nematode from the football field.
Yeah, so this one, if you look really closely at its mouth, which is what you're looking at here in this frame, it has a tooth. It has a really large cavity, first of all, compared to like a bacteria feeding nematode, which would have a really narrow mouth cavity. This one has a much larger one, and there's actually this triangular shape inside of it that would help kind of cut into whatever it's feeding on.
And our next one is a rotifer.
So rotifers, generally we kind of classify them as ciliates, but they're a multicellular organism. They are really fun to observe because they have rotors around their mouth parts that literally vacuum up bacteria. It creates a current to like draw the bacteria closer to itself. And then it has this interesting shape where it kind of inchworms whenever it wants to stay in a relatively close proximity to wherever it is, but then it can also zoom off like it does towards the end of that video just because it has the cilia around it.
I was going to say that one, if the Dallas Cowboys could move that fast, they never lose a game.
That's right.
And also something important to understand about rotifers is they are facultative anaerobes, so that they can live in oxygen, or they're oxygen tolerant anaerobes, I should say, which is good. They're very, very helpful in transitioning dirt into soil. That's primarily what one of the main ingredients is. I aerobically stabilize till I get those and not further, because what you're saying about the nutrient cycling is incredible. If you're sweeping that much bacteria into your mouth, how much greater is your poop that's coming out versus, say, an amoeba or flagellate? 100 times, maybe 1,000 times greater.
And this is supposed to be a naked amoeba.
Yeah, so this blob, I love a good blob. This one is slurping up bacteria so that the body of it's actually accumulating bacteria. And then you'll see kind of this circle on the inside of the amoeba that's a vacuole. And my understanding is that that's where a lot of the waste is being deposited. And then at some point, it will kind of flush that out of its body, empty that vesicle, and that's releasing plant available nutrients into the root zone. That was from one of your composts too, Leighton.
And we have a rotifer and an amoeba on this one.
This one's cool because you can actually see the valve inside the rotifer that's working to digest, like, move the bacteria through its body, which is pretty cool. And then as we focus in at the bottom here, it looks like there's actually two testated amoeba side by side there. So this large piece of organic matter off to the left was probably just a fragment of a root or leaf.
Have you ever seen kissing nematodes?
Oh yeah, they're like budding. They kind of look like yeast budding.
Yeah, they're actually, I believe that's how they divide.
Yes, yeah, it is. So this is a fungal feeding nematode. So this is actually at 100x, where all of our other videos so far have been at 400 times magnification. So this just goes to show how large that organism is. It takes up the whole screen at a quarter of the magnitude. So
that's
the
a
fungal,
large one.
the fungal feeding nematodes have a spear in their mouth part, and that's to kind of launch into the side of hyphae and suck some nutrients out.
And then next we have another fungal feeding nematode.
So this is like
times.
Yeah, thank you. This is at 400 times. So this is actually getting a closer look at that spear on the front of its mouth. I also find that fungal feeding nematodes tend to have kind of like a pucker. I think of it as like a suction cup. Like when they go to feed on hyphae, it's probably helpful to have some amount of surface area that's stabilizing their mouth part while they stick the spear into the hyphae.
If they didn't have that, the spear would launch them off the fungi.
Yeah, they just like bounce back.
This is another 100 times fungal feeding nematode.
You can tell which organism is my favorite lately by what I sent Ken. I'm really into fungal feeding nematodes right now.
And that's it for the slideshow.
Cool, thank you.
Well, Ab, is there anything else that you'd like to pick Andie's head on? Because I get to talk to her all the time. So
no, I did notice that one of the questions was about looking, and maybe Leighton, you answered this, but I noticed that I think it was one of the questions was about doing some DNA testing. And what are your thoughts around that, as opposed to getting to maybe a species level or
my thoughts on that. I think my thoughts are evolving on that. So Leighton pointed out some points that I think, DNA testing, similar to microscopy services, is there's like an economics story there to consider. So these tests tend to be more expensive than what most people are willing to spend for the sake of their agricultural fields, for example. But I think they can be a really useful tool in research and getting more specific data. Whether or not we can interpret that yet or not, I still think it's worthwhile to do DNA testing so that that we're collecting that data and we have basically an archive to start creating some of these connections. And the only way to do that is to have the data set available. Yeah.
I have one other question, and Leighton's brought this up many times. If you're buying bugs in a jug, we don't always get what's on the label. What can you offer if somebody wanted to buy an inoculant and they could send it to you? What would you come back and be able to tell them?
Yeah, I do that for people that buy a product, as opposed to creating an amendment themselves. They can send it for a full analysis, or they could send it just for a fungi to bacteria ratio. I'm willing to get creative with people. Like if they don't want a full assessment, we can at least just capture some amount of information to let you know if it's kind of a pass fail rather than this, rating in all areas. And I think that's the biggest thing people want to know about a bug in a jug is this garbage or is this actually healthy? And that's kind of more of a pass fail. Is the way that I see that. Chris from the Cowboys has even sent me stuff, and he's like, "Tell me if I'm wasting my money." And it's like I put a drop on, and there's just nothing in there. So it happens. And I think the microscope is a useful tool to eliminate some of those the time and money that we spend on solutions that aren't actually doing much for us.
And I did want to point out that Matt Powers is trying to put it together exactly what you're talking about, a complete list of everything
Yes.
biological.
Yes.
Yes. And there's others working on this too, you guys. There's a number of people that are assembling. A lot of universities have begun to build the database, but we're really going to need AI. Someone's going to have to get crazy and create a program that can digest this information. But we've still got to begin to understand what their actions are and reactions are in the soil system, or otherwise we can identify them, but we don't know what they're truly doing. So a lot of work left to be done on that one, unfortunately.
Yeah, right on. I know.
But
I do appreciate you brought up Matt Powers, Ken, and I just appreciate that he has a very interdisciplinary approach to this, in the sense that getting people talking to each other. So it's not siloed off. There's no gatekeeping of information, like giving the power to the people who are interested in this and doing work out of their homes like I am, and offering us a platform to share that data and learn from it collectively. And that feels pretty unprecedented. So I feel really grateful to be doing this work in this time where we have the technology and resources and ability to share information together and do like essentially citizen science, rather than relying wholly on academia as the only method of discovery.
Agreed 100%. Well, with respect to you, we've gone over 2 hours, so I don't want to tie you up because I know how busy you are right now. Get back to my samples, will you?
I know. I got more stuff coming. All right. Thank you guys so much.
Thanks.
Oh,
thanks
thank
so much,
you.
Andie.
Thank you, Andy, so much. Much love.
Thank
you, Av.
Yes.
And Ben, thank you for all the work that you do behind the scenes. I truly appreciate both of you very much. I think with that, unless you guys have anything else closing information, I guess we'll close it down.
Okay, I guess we're closing it down. I'm not sure if we're going to have a guest next Monday or not, or if I'm just going to let our soil mentors here just chop it up for another show, going over some of the stuff that has been covered in the last few shows, because there has been just so much knowledge and information that has been shared. I don't know. It's going to be up to you guys.
All right. Well, we can have a conversation after this, but I also wanted to remind you, or to thank you again, Andy, for all the work you did with Kyle Moat. That was critical, and we had him on last week, which is why we rolled you out this week. But we never got to that one. And she actually had like 3
I know. What? Y'all went pretty deep. Y'all went pretty deep on it last week, so I appreciate what you shared there. Yeah. Good.
Cool.
Well, you've been amazing, Andy, and I really appreciate your sharing those videos with me. They're absolutely amazing. And any more you want to send my way, I won't say no to. And Leighton, that goes for you too. You should have some videos like this, don't you?
Oh, yes, I got probably a ton on here, but I've been buried, buddy. I've been freaking buried. Ask her. I buried her in soil samples, and she buried me in test results, and now I got to catch up.
I was like, he was being so accusatory, like, you buried me this week. And I was like, well, I only buried you because you buried me last week. So
what comes around goes around. Is that what you're saying?
Yeah. Tit for tat,
Now you know why I love her. She's an amazing woman.
Yes, definitely. Okay, guys, if that's everything, if we don't have any announcements that we need to make, then I think we'll end the broadcast here.
All right. Sounds good.
Nice to see you.
Okay, everybody. Thank you very much for our chat. Don't forget, guys, subscribe, share. This is the information that everybody needs to get their hands on. So don't be afraid to share it out. So with that, guys, peace out, everybody, and we'll see you next Monday.